is you could, before we even try to evaluate the derivative, you could just multiply these two parentheses together, rearrange it algebraically. So x times 1 makes x times negative sine x makes negative x sine x, cosine x times 1 makes cosine x, and cosine x times sine x makes negative sine x cosine x. And when we evaluate the derivative, we do it term by term. So the derivative of x is 1. The derivative of x sine x, that needs the product rule. So if you're doing it this way, just watch out. You've got to wrap up the result of the product rule into parentheses. So the derivative of f times g plus f kept the same times the derivative of g. So that'd be cosine x. The derivative of cosine is negative sine. And then here we also need the product rule. So make sure you put the results of the product rule in parentheses if you're doing it this way. Derivative of sine is cosine. And then it's times the cosine. Plus the derivative of cosine is negative sine. So that's sine f times the derivative of g. And then we got some combining to do. Who's to say which one's easier though, huh? So this is, if we distribute that minus sign, it's 1 minus sine x minus x cosine x, then minus another sine x. Then here, if we distribute that minus sign, that's minus cosine squared x minus sine squared x. But I'll show you what we can do over here on the right to make that simpler. There's our Pythagorean identity. If you just factor out a negative 1, we'll combine these while we're at it. That's 1 minus 2 sine x minus x cosine x. Then here, I'm going to factor out the negative 1, and that leaves me with cosine squared x plus sine squared x, which is a Pythagorean identity, right? Sine squared plus cosine squared makes 1. So this is 1 minus 1 makes nothing. Oh, I got something different, didn't I? That's not good. I must have messed something up, because that's going to give us this, which is different than what we had before. Let me go back and check. Distributed x minus x sine x plus cosine x. That's right. That's right. That's right. That's right. Oh, right here. This is supposed to be a minus. Oh, so then I can't use the Pythagorean identity because you distribute that, that's a plus. So this can't happen. So close to using it, huh? We do the same thing we did in the other approach. 1 minus cosine squared makes sine squared. So those can combine like we saw in the other approach. Oh, here, and while I'm at it, look, minus sine x, we already said that those can combine to make minus 2 sine x. We got x cosine x plus sine squared x. So these two can combine because they're the same term. So we got 2 sine squared x minus 2 sine x minus x cosine x. Okay. And which is the same thing we got with the other approach. Two big ways we could handle this. You could consider this first parentheses f of x, and then the second parentheses g of x, and then you could use the product rule because it's an f of x times g of x, two different functions of x being multiplied. So if you want dy dx, in other words, if you want the derivative, then it's the derivative of f of x, which is 1 plus, it's going to be 1 subtract sine x times 1 minus sine x times g of x kept the same. Look, in the derivative, you can do it term by term. Derivative of x is 1. Derivative of cosine is negative sine. So that's and we're using the product rule. We've done f prime times g. Now we need to add it to f times g prime. So we've got the original f function, and the derivative of g is going to be negative cosine, because the derivative of sine is cosine. So the derivative of negative sine is negative cosine. Okay, and then we could clean it up. Thinking what would be the easiest way. I mean, this is going to be, I don't know if it would be better to expand it or not by looking at it. This is going to be 1 minus sine x squared because it's something times itself, right? And then over here, if you distribute that negative cosine x to everything on the inside, that's negative x cosine x subtracted by cosine squared x. I mean, the calculus is done. The rest is just simplifying. I'm going to expand, and the reason is because I've got, no, that's not going to help. I was trying to use sine squared plus cosine squared equals 1. That could still happen, but we're going to get a positive sine squared here, so that won't help us. I don't know, that might be as neat as it can go. But if you, instead of wrapping that up as 1 minus sine squared, if you were to multiply these out, 1 times 1 would make 1. 1 times negative sine x would make negative sine x. And then you're going to get another negative sine x, so that's negative 2 sine x. And then negative sine times negative sine makes positive sine squared. So I wanted to use one of the Pythagorean identities, but it doesn't work because 1's minus, 1's plus. But there is actually an identity we can use. Sine squared plus cosine squared equals 1. So in other words, 1 minus cosine squared equals sine squared. Okay, that comes from the equation sine squared plus cosine squared equals 1. So right here I've got 1 minus cosine squared. Those can combine using the Pythagorean identity to be sine squared. I'll copy everything else down. And we've got sine squared plus sine squared, that makes 2 sine squared minus 2 sine x minus x cosine x. And that's as simple as I think I can imagine it.